Have you ever found yourself completely swamped by a new technology? Staring at a blank screen and wishing there was just a shortcut, maybe a fast lane to understanding it, and, well, even better, to building with it.
Mhm.
Or maybe you're an entrepreneur with a brilliant app idea, but the sheer complexity of traditional software development just feels like this impossible mountain to climb.
I think a lot of people feel that way.
Well, get ready, because today we're peeling back the layers on what feels like a true paradigm shift,
Mhm.
something that promises to make software creation radically, almost unbelievably easier.
Yeah, it's a big claim.
Okay, so let's unpack this. Today, we're taking a deep dive into something called vibe coding. Now, I know what you might be thinking, another tech buzzword, right?
Yeah, there are plenty of those.
But believe me, this isn't just some fleeting trend. This feels like a profound, maybe even revolutionary way of interacting with computers to build software. People are saying it's already reshaping the very landscape of creation.
It absolutely is. And the term vibe coding, it was actually coined and really rapidly popularized by the computer scientist Andrej Karpathy,
Yeah.
a brilliant guy.
Right.
He introduced it, I think it was on social media back in February of 2025.
Hmm.
And he described it as a process where you fully give in to the vibes, embrace exponentials, and forget that the code even exists.
Forget that the code even exists. Wow.
Yeah, that phrase, it really captures this intuitive, almost symbiotic relationship you can develop with an AI coding partner. And the resonance, like you said, it was immediate,
It really took off fast.
incredibly fast. It wasn't long before it actually landed in the Merriam-Webster dictionary as a slang and trending term. That was just a month later, March 2025.
Of a month? That's wild.
Shows you how quickly it just permeated the tech lexicon.
That rapid adoption is amazing. It's like the collective tech world immediately felt what he was talking about. It clicks, doesn't it? Especially when you think about Karpathy's earlier prediction. That was famous too, back in 2023.
Oh, yeah, the hottest new programming language is English.
Exactly. Vibe coding feels like the practical realization of that vision. A future where, your conversational intent, just your plain language description of what you want,
Mm-hmm.
that can command incredibly complex computational tasks. And you don't need to master all that deep syntactical knowledge first.
Right. It's a huge shift.
It feels like the latest, maybe the most powerful wave in what we've been calling the great democratization cycle of technology. We saw it first with photography, right?
Mhm.
Suddenly, everyone had access to tools that used to need a darkroom and tons of expertise.
Digital cameras, Photoshop.
Yeah.
Yeah, it changed everything.
Then publishing, anyone with a laptop could be an author. Music production, same thing. Studio quality tracks on your home computer. And now, software development, which always felt like the last bastion of, highly specialized knowledge, it's next.
It really seems that way. So our mission today for you, our listener, is really to pull back the curtain and explore what vibe coding truly is. We're going to dive into its incredible, almost seductive promises, the amazing things it allows you to do, often with unprecedented speed.
But it's not all sunshine, right?
No, definitely not. We also need to be really clear-eyed about its hidden perils. There are significant risks that often lurk just beneath the surface.
Okay.
And ultimately, we want to help you understand what this all means for anyone looking to build something with technology, whether it's just a simple idea for a personal project, maybe a weekend hack, or even a complex mission-critical product for a global business.
All right, let's start at the beginning then. We've heard the term, we get the big picture context, but what is vibe coding, really, at its core? How do we define this paradigm that feels, well, both revolutionary and maybe a little unsettling for some folks?
Well, fundamentally, I think the core idea is that vibe coding. It's essentially an AI-assisted software development practice.
Right, AI assisted, so not replacing the human, but helping.
Exactly. It means the developer uses natural language prompts. Just plain English mostly, or whatever language you prefer.
Okay.
And they use these prompts to tell a large language model, an LLM, what to do.
Like instruct it.
Yeah, instruct it to generate the code, or maybe refine code that's already there, or even, help debug functional code. It's a fundamental shift from how software has traditionally been built.
So if the AI is doing the coding, or a lot of it, what does that really leave for the human developer? How does their day-to-day actually change? Is it less typing?
It definitely involves less typing of raw code. The human's role shifts pretty dramatically, actually. You're no longer the meticulous author of every single line of code, painstakingly crafting each statement.
Okay.
Instead, you become more of a high-level director, maybe a guide, a prompter, and crucially, a tester.
A director and tester. Interesting.
Yeah, your input moves away from that precise syntactical code writing lines of Python or JavaScript,
Yeah.
and it moves towards plain language descriptions of your intent.
Can you give an example?
Sure. So instead of writing out all the HTML, CSS, and JavaScript for a login form, you might just say to the AI, create a user login form with fields for email and password, and add a forgot password link.
Much simple.
Or, write a Python function that reads a CSV file, skips the header row, and calculates the average of the third column. The AI handles the intricate, low-level coding part. Your job is really to tell it what to do, much more than how to do it.
That sounds incredibly powerful, like a superpower for getting things done quickly. But
Yeah.
I can already hear the gears turning for some of our more traditional engineering listeners. The term itself, vibe coding, it feels like a double-edged sword, doesn't it?
It absolutely is. You nailed it. That's a really critical point. On one hand, its informal, kind of playful nature makes the whole concept incredibly accessible. It's appealing, especially to non-technical users, designers, creatives, people who might have felt intimidated by coding before.
Right, it lowers the barrier, democratization.
Exactly, which is a huge positive.
Yeah.
But here's the other edge of the sword. That same framing risks obscuring the inherent complexities and, frankly, the significant risks involved.
How so?
Well, it can alienate experienced software engineers. They might see it as a dismissal of the rigor, the discipline, the skill that's actually required to build robust, secure, maintainable software. They hear vibe coding, and they might think shortcuts, sloppy, not best practices.
Yeah, I can see that.
Ah.
And I can easily imagine how that creates a huge communication gap, especially inside companies.
Oh, definitely.
You've got a non-technical manager hearing vibe coding and maybe envisioning this magical instant creation process. They're thinking, great, we'll have that complex feature by next Tuesday.
Right, the magic wand idea.
But then the experienced engineer hears that same term and they think they're being told to just, throw out everything they know about good engineering. Abandon best practices, pile on technical debt like there's no tomorrow.
And that disconnect is huge. That fundamental difference in expectations, often fueled by this oversimplified buzzword. It's a critical issue. It can genuinely set a project up for failure before you even type the first prompt.
It's like they're speaking completely different languages about the same concept.
Pretty much. Which, raises an important question. Given these vastly different interpretations and expectations, what does vibe coding actually look like in practice? Because it's not just one single thing.
Right.
It really exists on a spectrum. And that spectrum is defined mostly by the degree of human oversight. And critically, how much the user actually understands the code that's being generated.
Okay, a spectrum. So what are the ends of that spectrum?
Well, we can typically divide it into two main approaches, or maybe modes of operation.
Let's unpack those. What's at one end? The one that probably gave the term its name, I'm guessing.
Yeah, exactly. At one end, you have what people call pure vibe coding. This is the most exploratory, maybe the most extreme form of the practice.
Well, okay, pure. What does that involve?
In this mode, the user really fully trusts the AI's output. They often accept and run the code without necessarily having a deep, line-by-line understanding of its mechanics.
So just trust the machine.
Pretty much.
Ah.
A key part of this definition is that the user accepts the code without full comprehension. And often there's an implicit acknowledgement that, yeah, there are probably going to be some bugs, some glitches.
And who uses this pure approach?
Karpathy, when he first framed it, suggested it was best suited for things like rapid ideation, what he called throwaway weekend projects, or maybe software for one, highly personalized tools where speed is absolutely the top priority. And long-term maintainability just isn't a concern at all.
Right, like sketching with code, as you said. Just get the idea down fast.
Exactly. You're not building a cathedral, you're just sketching on a napkin.
Okay, so that's one end. Fast, experimental, maybe a bit disposable. What about the other end of the spectrum? The more professional, perhaps more responsible application?
That's where we talk about responsible AI-assisted development. This really represents the professional and practical application of the concept.
How does that work?
Here, the AI tool functions more like a powerful collaborator. Or maybe think of it as a highly advanced pair programmer.
Okay, a partner.
Yeah, but the key difference is the human developer remains firmly in control. They guide the AI's generation process, absolutely, but then they critically review, they test, and crucially, they understand the code it produces.
Understanding seems key here.
It's everything. In this model, the developer takes full ownership and full accountability for the final product. As a programmer, Simon Willison put it really well. He said, if an LLM writes every single line of code, but the developers reviewed it, tested it, and genuinely understood it all, like truly understood why it works and how it works. That's not really pure vibe coding anymore.
What is it then?
That's actually the responsible and incredibly powerful use of an LLM. It becomes this hyper-efficient typing and scaffolding assistant. It frees up the developer's mental energy for the higher-level problems, the architectural decisions.
That's a really important distinction. It's not about letting the AI just run wild. It's about leveraging it as this super fast assistant. Like having a brilliant intern who never sleeps but still needs really strict supervision and guidance.
That's a great analogy. And this leads to the workflow itself.
Right. How does the actual workflow happen in these scenarios? Is there a typical process, like a loop you follow when you're working with the AI?
Yeah, there is. Regardless of where you are on that spectrum, from pure to responsible, the fundamental workflow tends to operate as a very tight, very conversational and iterative loop.
Okay, break that down.
It usually starts with describing the goal. You give a high-level prompt in plain language.
Step 1, prompt.
Right. Step 2, the AI generates code. It interprets your request and spits out an initial version.
Okay, AI codes.
Step 3, you execute and observe. You run the code, see if it actually does what you wanted.
Yeah.
Does it work? Does it crash?
Test it out. Makes sense.
Then step 4, provide feedback and refine. If there's an issue or even if it just needs improvement, you give new instructions. You might paste an error message back to the AI or say something like, okay, that works, but now add robust error handling for when the file's not found and make sure it logs any errors to this specific file.
So you guide the refinement.
Exactly. And finally, step 5 is just repeat. You keep going through this cycle, describe, generate, test, refine, until that particular code block or feature is complete. It's this dynamic back and forth dialogue. Honestly, it feels a lot like a conversation with a human colleague, just, at a vastly accelerated pace.
Okay, that workflow makes sense. But you mentioned earlier that even with this spectrum of pure versus responsible, in the real world, it's more like a strategic battleground. What did you mean by that? What's the actual fight over in organizations?
Yeah, that's a really vital point for anyone trying to navigate this space in a company. While this pure versus responsible distinction seems clear on paper, in organizational reality, it's often more of a strategic battleground than a stable choice the developer makes.
How so?
Because that seductive promise of extreme speed from the pure approach, it's incredibly attractive to non-technical stakeholders. Think CEOs, product managers, sales leaders. They see it as this potential magical solution to accelerate development by tenfold, even for production applications.
They want the speed for everything.
Exactly. They start thinking they can cut months, maybe even years, off a development timeline. And this creates this intense, high-pressure environment. An experienced developer who naturally understands the risks and would advocate for a responsible, more careful methodology. They might get pushed by management, maybe implicitly, maybe explicitly, to just cede more control to the AI, just to try and meet what quickly become unrealistic, often unstated timelines.
So the real danger is misapplying a tool. Using something meant for, say, a quick hobbyist project for a serious professional problem that actually needs rigor and long-term thinking.
Precisely. That's the heart of the danger. The misapplication of a methodology really intended for throwaway projects onto critical, long-lived production systems. And that inevitably leads to the creation of unmaintainable, insecure, incredibly fragile software that becomes a huge liability, not an asset.
Right.
So the true dividing line, when you look at it organizationally, isn't really the developer's personal choice of methodology. It's more about the organization's cultural commitment. Do they enforce engineering discipline, things like rigorous code reviews, thorough automated testing, comprehensive security audits, or do they prioritize the powerful, almost intoxicating allure of unchecked velocity above all else?
It's a fundamental tension.
It really is. A constant tension between that desire for speed and the absolute need for quality, security, and sustainability.
This really sets up the core conflict. What exactly are the wins we're seeing from vibe coding? And on the flip side, what are these major risks? It sounds like there's a profound dichotomy here, a really high-stakes trade-off.
There absolutely is. It's definitely a high-stakes trade-off. On one hand, as we've touched on, it offers this unprecedented speed and accessibility. It could potentially unlock a whole new wave of innovation across different industries.
The promise.
The promise. But on the other hand, it introduces this host of really severe risks, things related to code quality, security vulnerabilities, long-term maintainability. It's like a powerful engine, definitely. But it comes with some serious warning lights flashing.
Okay, let's start with the good news then, the wins. What stands out for you as the clearest benefits?
Well, the most celebrated benefit, and the one that really resonates with that democratization cycle we talked about, is its ability to dramatically lower the barrier to entry for creating software.
Making it easier for more people.
Exactly. It truly empowers a whole new class of creators. We're talking non-programmers, hobbyists, designers, product managers, even entrepreneurs. It allows them to build functional applications without needing to first master complex programming languages or intricate syntax or those daunting frameworks.
And that has real impact?
Huge impact. This democratization means that individuals who have deep domain expertise, imagine, say, a healthcare professional who needs a very specific data analysis tool for their research, or maybe a financial analyst who wants to automate a complex reporting process.
Yeah.
They can now potentially translate their ideas directly into tools and solutions. They don't have to wait for or maybe even hire a dedicated development team. That's a massive win for innovation and just practical problem solving. It opens up avenues that were basically closed off before because of those technical barriers.
So it's not just about existing developers getting faster, it's about bringing a much broader range of people, domain experts, into the actual creation process.
That's powerful. And what about the core promise? The speed. The name vibe coding itself implies extreme velocity. Does it actually deliver on that?
Oh, it absolutely does.
Yeah.
In pretty astonishing ways, vibe coding offers a massive acceleration of the development process, particularly in those crucial early stages of a project.
Like prototyping.
Exactly. It's exceptionally well suited for rapid prototyping, for creating minimum viable products or MVPs, and for developing proofs of concept just to quickly test and validate ideas in the market. The impact on velocity can be truly dramatic.
Any examples?
Yeah, we've seen documented case studies where a production-ready MVP was built in as little as 2 weeks.
2 weeks for production MVP. Yeah, a timeline that would have been pretty much unthinkable just a few years ago, especially for a small team. And there's another compelling example of a non-technical founder, someone without a coding background, who was able to launch a revenue-generating software as a service, a SaaS product, within just a few months.
Wow.
They essentially proved out a viable business model with minimal upfront engineering investment. Imagine that, taking a concept from just an idea to a product actually earning revenue in a fraction of the traditional time. That's genuinely unprecedented, and it's a potential game changer for entrepreneurs.
That's incredible. It sounds like it really allows people to shift their focus away from the nitty-gritty lines of code and more towards the bigger picture, right? Like solving the actual business or user problem.
That's exactly right.
Yeah.
By automating the generation of all that boilerplate code and handling those tedious, repetitive tasks that just consume so much developer time.
Like setting up projects.
Yeah, setting up basic file structures, writing standard CRVOD operations, create, read, update, delete, generating API endpoints, all that stuff. Vibe coding frees creators to focus on higher level, more strategic concerns.
So less time on the plumbing, more on the architecture.
Pretty much. Instead of getting bogged down in syntactical details or wrestling with obscure compiler errors, developers, and even non-developers, can concentrate on the core idea, the user experience, solving the actual business problem. And this shift, it seems to foster a more creative, maybe more playful and experimental mindset that can lead to greater innovation, maybe more daring attempts at new solutions, because the cost of trying is so much lower.
And we've already seen some really cool practical examples of this in action, haven't we? It's not just theoretical benefits.
No, not at all. Enthusiasts and professionals are actively using these techniques to build a really wide array of useful applications every single day.
Like what?
Well, think about practical tools like a plywood cutting visualizer, something to help optimize material usage and minimize waste for woodworkers.
Yeah.
Or a personal portfolio website that's enhanced with a custom AI chatbot that can actually respond intelligently to visitor questions.
Nice.
People have built things like admin dashboards for popular databases like Supabase, making it easier to manage their data. Or even an SEO calculator designed specifically to serve as a marketing lead magnet for their business.
Clever.
There's even a creative service out there that automatically turns your Spotify playlists into physical postcards. And you see lots of various utilities being built for the WordPress ecosystem to automate common tasks for website owners.
So lots of practical tools.
Definitely. And beyond building entirely new applications, it's also proving to be a really powerful learning tool. It enables experienced developers to quickly experiment with and learn unfamiliar programming languages, or new frameworks, or maybe third-party APIs without a huge time investment.
How does that work?
Well, you can instantly generate code in a language you've maybe never used before, see it work almost immediately, and then you can dissect it, try to understand how it was put together. It accelerates that learning curve.
Okay, so the wins are pretty significant. Much greater accessibility, incredible speed, especially early on, fostering creativity, and we're seeing lots of practical applications already. But now, let's turn to the flip side. You mentioned severe challenges and risks. What are the major pitfalls we absolutely need to be aware of here?
Yeah, the challenges are definitely significant. And if they're not managed really carefully, they can quickly undermine a project's long-term viability and even expose organizations to pretty critical risks.
Okay, like what? What's
Yeah.
the biggest concern?
Well, the most frequently cited criticism, especially when vibe coding is used without that rigorous oversight we talked about, is that it tends to produce low quality, poorly structured, and often basically unmaintainable code.
Instant technical debt.
Exactly. It's often described as a method for creating instant technical debt. It can generate what one source vividly called a monstrous hulk of code.
A monstrous hulk. Doesn't
Right.
sound good.
No. Think of it like building a beautiful house that goes up incredibly fast. Looks amazing from the outside. But when you look closely, the plumbing is a total mess. The wiring is exposed and maybe unsafe, and the foundation itself is shaky.
So it's hard to work with later.
Incredibly difficult to understand, to refactor, or to build upon safely. And even when you ask the AI to refactor the code, to clean it up, its attempts can sometimes be purely cosmetic. It might even ironically increase the complexity by creating confusing and unnecessary dependencies between different parts of the code rather than actually simplifying the code base.
So it looks cleaner, but it's actually more tangled underneath.
Precisely. It might look clean on the surface, but structurally it's not sound.
Instant technical debt and a monstrous hulk of code. Yeah, that sounds like a complete nightmare for anyone who has to maintain that system down the road. But what about security? That's always a paramount concern, especially when you start talking about enterprise applications with real customer data.
This is, without a doubt, probably the most acute and the most dangerous risk associated with vibe coding, particularly the pure approach. It's a massive blind spot for a lot of people getting excited about the speed.
Why is it so risky?
Well, you have to remember how these AI models are trained. They learn from vast data sets of public code scraped from the internet, places like GitHub, Stack Overflow.
Right, huge amounts of code.
Huge amounts. But unfortunately, that public code includes countless examples of insecure programming practices, maybe use of deprecated libraries with known flaws, and sometimes outright vulnerabilities.
So the AI learns the bad habits too.
Exactly. As a result, the AI-generated code often contains hidden and sometimes severe security flaws, simply because the AI is replicating patterns it saw in its training data, good and bad alike. There was a really notable academic study, quite concerning actually.
What did it find?
It found that approximately 0% of the code generated by GitHub Copilot, which is one of the most popular tools, contained potential security flaws that could likely be exploited by attackers.
40%. Seriously, that's a huge number, almost unbelievable.
It is. Nearly half the code has a potential weakness baked in from the start.
Wow. Are there like real world examples of this going wrong, of these consequences actually playing out in production systems built this way?
Unfortunately, yes. And the consequences can be pretty stark. In one documented case, a software-as-a-service application that was built primarily using vibe coding suffered a truly catastrophic security failure.
What happened?
Multiple things. Its entire user list was leaked publicly. Its Stripe payment processing key was compromised.
Oh no.
Yeah, which then led to hackers being able to issue fraudulent refunds to all of the company's customers. Imagine the financial hit and the trust lost there.
That's devastating.
And on top of that, the application was subjected to ongoing cross-site scripting, or XSS attacks. For those maybe unfamiliar, an XSS attack is where a malicious code gets injected into a website, and it can then steal data from unsuspecting visitors, hijack their sessions, or even deface the site.
So really common but dangerous vulnerabilities are more likely.
The risk of those common but critical vulnerabilities, things like SQL injection, insecure authentication mechanisms, sensitive data leaks, it's exceptionally high. Because, again, the AI is just replicating patterns it's seen, both good and bad, without necessarily understanding the security implications.
And attackers are fast.
Incredibly fast. And the speed of exploitation is a major concern, too. Some reports indicate that sensitive credentials, like API keys, if they're accidentally exposed in code, pushed to a public place like GitHub, They can be found and exploited by automated bots within minutes,
Mi-
sometimes faster than you can blink. This isn't just theoretical risk, it's actively happening out there, with real financial and reputational consequences for businesses that aren't careful.
Okay, so we've got low-quality code, potentially riddled with security holes. What happens when it inevitably breaks? You mentioned something called vibe debugging earlier. That sounds, well, stressful.
It is. Stressful is a good word for it. Debugging AI-generated code is notoriously difficult and often incredibly frustrating, especially for a non-technical user, but even for an experienced developer who didn't actually write or deeply understand the code in the first place.
Why is it so hard?
Because the developer often lacks that deep intuitive understanding of the code's underlying structure, its logic, and maybe the AI's thought process, quote unquote, in generating it. They can't reason about its failures in the same conventional way they would with code they wrote themselves.
So you can't easily trace the problem.
It's much harder. And this has led to that term, vibe debugging.
Hmm.
It's often this painful, sometimes desperate trial and error process. You're basically just feeding error messages back into the AI chat window.
Hoping for the best.
Yeah, hoping that it will eventually spit out a fix that mostly works without really knowing why it works or if it introduced other problems. Imagine trying to fix a really complex machine when you could only describe the symptoms and kind of guess at the cause, rather than having the schematics and understanding how it's built.
That sounds maddening.
It really can be. And this whole experience, creates this profound sense of detachment from the code base. Developers become incredibly reluctant to modify or extend this confusing, fragile system they've inherited or created this way because any change feels risky.
It becomes a black box nobody wants to touch.
Exactly. It's truly a maintenance hell that can quickly negate any of those initial speed gains you thought you were getting.
And beyond just individual bugs popping up, what about the overall performance and scalability of these vibe-coded applications? Can they actually handle real-world loads, lots of users?
Generally speaking, vibe coding, particularly in that pure form, is considered pretty unsuitable for building complex distributed systems or high-performance applications, the kind that need to handle many concurrent users or process large amounts of data efficiently.
Why not?
Well, prototypes built really quickly with AI assistance often struggle to scale effectively. This is usually due to things like inefficient algorithms being chosen by the AI, or maybe unoptimized database queries.
Like asking for way more data than needed.
Yeah, a classic example is the AI generating a select command on a massive database table when it only actually needed one or two specific columns. That kind of thing kills performance. And there's often just a general lack of sound architectural planning up front. There's no human architect thinking about future load or designing for modularity and resilience.
So it works fine for one user, but falls over with 1,000.
Pretty much. As the codebase grows and more users come online, these fundamental inefficiencies become much more pronounced. That leads to poor performance under load, maybe slow response times, and often surprisingly expensive infrastructure bills because you're using resources so inefficiently. It's just not built for the long haul, and it's raw, vibey, unreviewed form.
Okay, you mentioned technical debt earlier, which I think many of our listeners are familiar with. That's sort of knowingly taking a shortcut now that you know you'll have to fix later. But the sources also talk about something even deeper, maybe more insidious, epistemic debt. Can you explain that concept? It sounds really important.
Yes, this is where it gets really, really interesting, and I think it's a crucial concept for everyone to grasp, especially leaders. The conventional idea of technical debt, knowingly taking a shortcut, maybe building a temporary solution to hit a deadline, understanding you'll refactor it later, that concept is actually insufficient to capture the full liability introduced by certain ways of using vibe coding.
It doesn't cover everything.
No. Vibe coding, particularly that pure approach where you don't fully understand the output, creates a much more insidious form of liability, something we can call epistemic debt.
Epistemic, like relating to knowledge?
Exactly. It's a debt of knowledge. Think of it like this. Traditional technical debt is like a loan you knowingly take out.
Yeah.
You understand the interest rate, you'll probably have to pay it back with extra effort later.
Right.
But epistemic debt from pure vibe coding, that's more like inheriting a house where you don't even know what's behind the walls. You have no idea what condition the wiring is in or how the plumbing works or how to fix a leaky pipe when it inevitably starts dripping.
Because you didn't build it and you don't have the blueprints.
Precisely. It's a debt of knowledge, not just a debt of messy code. And that makes it far more dangerous because you often don't even know the extent of what you don't know. Remember, the central tenet of pure vibe coding is often the acceptance of code without full understanding.
So it's not just that the code might be bad, it's that no one really knows why it might be bad or how to fix it properly because they didn't really understand its creation in the first place. It becomes this unmaintainable black box.
That's the core of it. When a bug inevitably appears, or maybe a new feature request comes in that requires changing that code, the cost of repayment isn't just the time to refactor a specific piece of code you understand. It's the immense time and effort required to basically reverse engineer and learn the entire system from scratch just to make a change safely.
Which could take way longer than building it right initially.
Often, yes. This epistemic debt is far more dangerous because it's often hidden. A system can appear to be functioning perfectly correctly, running smoothly for weeks or months, while secretly accumulating this massive, invisible liability of incomprehensibility.
Until something goes badly wrong.
Exactly. The interest payments on this debt don't show up gradually. They manifest as catastrophic failures, maybe severe security breaches that seem to come out of nowhere, or just a complete inability to evolve the product, because any change risks breaking everything in unpredictable ways. And this often forces companies into a complete and incredibly costly rewrite from the ground up, effectively throwing away all that initial speed they thought they gained. It's like a ticking time bomb hidden in the code base for many projects built this way.
And this really makes it sound like that initial instant velocity that everyone gets so excited about. It can be a total illusion, can it? A mirage, as you called it earlier.
It absolutely can be. That narrative of accelerated development is often an illusion that merely shifts the effort rather than actually eliminating it entirely.
Also,
Well, vibe coding can certainly generate an initial prototype in minutes or hours. You get that exhilarating burst of speed right at the start, which feels amazing. But this initial burst is frequently nullified, sometimes completely wiped out, by the immense time and effort required later for all the debugging, the testing, and fixing the AI's flawed or poorly understood output.
so the real work comes later.
Users often report exactly that the real work only begins after the prototype is built. They find the majority of their time is consumed by that frustrating cycle of testing and that painful vibe debugging we discussed.
So it's not less work overall, just different work.
Or potentially even more work, just shifted.
Yeah.
Vibe coding doesn't magically reduce the total effort required to ship a quality, reliable product. Instead, it dangerously shifts that work. It moves it away from a structured, predictable, upfront design and development process.
Where you try to prevent problems.
Exactly, to a chaotic, unpredictable, and often much longer back-end process of reverse engineering, repair, and firefighting. It's like getting a super fast sports car on a high-interest loan. You feel incredibly fast leaving the dealership.
They're exhilarating.
But then the interest payments, the debugging, the security patches, the refactoring, the confusion, they start piling up so high, you realize you're spending more time just trying to keep the car from breaking down than actually driving it to your destination. That perceived velocity at the start, it's often a mirage that conceals the true and frequently much higher cost downstream.
That's a really powerful warning for anyone jumping into this. So, okay, if we acknowledge these very real risks, but also the undeniable power and potential of AI here, how are people actually using these tools effectively? What does the modern Vibe Coders toolkit look like today? And what practices are emerging to try and make it safer and more productive?
That's the right question. The rise of vibe coding, or maybe more broadly AI-assisted development, has absolutely been enabled by a rapidly growing ecosystem of specialized tools and platforms. They're all designed to make that human-AI coding interaction as seamless and productive as possible.
What kinds of tools are we talking about?
These tools really range from things like AI-infused integrated development environments, IDEs, all the way to full-stack generation platforms that claim to build whole apps, and also simpler in-editor assistants that just help you as you code normally.
And the choice depends on?
The choice of tool typically depends on a few things. The user's technical skill level, obviously the specific goals of the project, and maybe the desired degree of human oversight and control they want to maintain.
Okay, let's run through some of the popular ones people might be hearing about. Which AI-first IDEs are really leading the charge right now? The ones built around AI?
Right. Starting with those AI-first IDEs, which are really designed from the ground up for an AI-centric workflow, one popular example you hear a lot about is Cursor.
Cursor, okay.
It's an AI-first code editor that deeply integrates large language model capabilities into pretty much every aspect of the development process. You can select code, ask questions about it, get explanations, refactor it, or even generate entirely new functions, all directly within the editor environment.
Who's using it?
It seems to be widely used by both professionals, for maybe fine-tuning production code or speeding up common tasks, and also by hobbyists for that rapid prototyping we discussed. Then there's another big one, Replit.
Replit, yeah, heard of that. Cloud-based, right.
Exactly. It's a comprehensive cloud-based IDE, and it features these powerful AI agents it calls Agent and Assistant. These are designed to potentially generate, refine, and even deploy entire applications just from natural language prompts.
The whole life cycle.
That's the idea. It's all in one environment. It includes integrated databases, one-click deployment features. It makes it incredibly accessible, especially for beginners who just want to build something and get it online fast without wrestling with infrastructure.
Okay, so those are dedicated editors. What about platforms that claim to generate entire applications or maybe just the user interfaces from scratch, giving you something tangible almost immediately?
Yeah, for full stack and UI generation, we're definitely seeing some impressive platforms emerge. Google, for instance, offers AI Studio. That seems more geared towards beginners who are doing rapid prototyping, especially for generative AI applications themselves. And they also have Firebase Studio, which is aimed more at intermediate users building full-stack applications with an integrated Firebase backend.
Makes sense for Google. Any others making waves?
Well, there's a fast-growing AI startup called Lovable. They make some pretty bold claims, suggesting users can create working software products in literally minutes. They really showcase that extreme speed aspect we talked about. They're leaning hard into the instant product idea.
Minutes, wow. High bar.
Definitely. And then there's V0, which is developed by Vercel, a big name in web development.
Right, Vercel. What does V0 do?
It specializes specifically in generating React-based UI components directly from text prompts and even from image prompts.
From an image, like a sketch.
Yeah, you can potentially give it a mock-up image, and it tries to generate the corresponding React code. This is incredibly useful for designers or developers who need to quickly mock up a user interface without manually writing all the detailed HTML and CSS. It's really perfect for that quick UI prototyping in the very early stages of development.
Very cool. So we have these powerful, dedicated, almost pure vibe tools. What about just using general AI assistants within your existing workflow, like the tools many developers are already using, or even just general LLMs like ChatGPT?
Yeah, that's probably the most common scenario right now.
Yeah.
You have those in-editor assistants like GitHub Copilot, which is hugely popular, Google's Gemini Code Assist, Amazon's Code Whisperer.
Big players.
Exactly. These are arguably the most common forms of AI assistants for professional developers today. They function essentially as AI pair programmers directly within the established IDEs that developers already use, like VS Code or the JetBrains suite.
What do they do day to day?
They provide real-time code suggestions as you type. They can explain complex code blocks you're struggling with, and some can even generate entire test suites for your functions automatically. They integrate pretty seamlessly into a developer's existing environment and workflow.
And the general ones, ChatGPT, Claude.
Right. Then you have the general-purpose LLMs, like ChatGPT and Claude. For many people, these are actually the entry point into vibe coding or AI-assisted development. They're used constantly for generating quick code snippets, maybe brainstorming architectural solutions, or just getting help debugging tricky error messages by pasting them into the chat.
I do that all the time.
Many people do. And some, like Claude, even have advanced features now. Claude has something called artifacts that actually allow for the creation of simple, shareable web applications directly within the chat interface. You can describe it, it generates the code, and you can see it run immediately right there.
That's taking it a step further. It's a huge, burgeoning landscape of tools then. But what I find truly fascinating, and you alluded to this earlier when we talked about the risks, is how these best practices for actually using AI effectively are starting to emerge. And it almost feels like a regression to the mean, maybe. A return to traditional engineering discipline.
That's precisely it. It's uncanny.
It's like we try to throw out the rule book, maybe hit some walls pretty hard, and are now kind of systematically coming back to it, but applying it to AI.
That's one of the most insightful takeaways here, I think. If you critically examine the best practices that have emerged from the developer community using these tools, they are not revolutionary new concepts at all.
What are they then?
Instead, they are largely a powerful rediscovery, maybe a reapplication of traditional software engineering discipline, just adapted for this new AI-driven context.
So the old rules still apply?
It seems so. Remember, the initial promise of vibe coding, especially in its pure form, was this radical departure. a chance to forget the code exists, just let the AI handle everything. But practitioners who really followed that path, they quickly encountered chaos, unmaintainable code, security nightmares, and project failure.
The chickens came home to roost.
Exactly. So in response, the community's recommendations, the things people found actually work. They've converged on principles that directly mirror established engineering fundamentals. The call to use detailed product requirement documents, PRDs, that's just traditional requirements gathering.
Right.
The non-negotiable advice to use version control, like Git, that's a cornerstone of professional development, decades old. The guidance to break work down into small, manageable, testable chunks. That's the very essence of iterative and agile development.
So it all comes back around.
It really does. And this evolution strongly implies that vibe coding isn't actually a replacement for engineering discipline. It's a powerful tool, yes, and potentially a dangerous one that absolutely requires that discipline to be used effectively and safely. It's like giving someone a high-performance race car. If they don't know the fundamentals of driving, if they don't respect the rules of the road, it's far more dangerous than a regular family car.
That's a great analogy. So it's not about throwing out the rule book at all. It's about using the rule book to manage this new, very powerful tool. Okay, let's dig into some of these emerging best practices then. How do you actually plan and scope a vibe-coded project safely? Especially given that it's so tempting to just jump straight into coding with these tools.
Yeah, the temptation is strong. That's why, to mitigate those significant risks we discussed, planning and scoping become absolutely paramount, maybe even more so than traditional development, precisely because the tools make it so easy to skip these crucial steps.
So what's step one?
First, and this is key, you should absolutely use some form of product requirement document, or PRD. Before you write a single prompt, create a detailed plan. Break the project down to small, explicit, and ideally testable steps or features.
Why is that so important with AI?
Because it forces you, the human, to clarify your own thinking first. And second, it provides the AI with a structured roadmap, which reduces ambiguity and helps prevent those hallucinations or situations where the AI just kind of makes things up because the prompt was too vague.
Okay, detailed PRD. What else?
Second, for any project that's more than just a quick experiment, you should probably over-spec at the outset. Create a highly detailed specification document. Map out every page, every user workflow, the different permission levels, how systems need to interact. Get granular.
It sounds like a lot of upfront work.
It is, but this upfront investment in planning prevents incredibly costly rework later on. Because the AI isn't going to magically know your specific business logic or edge cases, you have to tell it clearly. And maybe the practical tip. Before committing to a real project, especially on a new AI platform you haven't used before, spend maybe just 60 minutes on a quick throwaway hack project, something small. Just to understand that specific AI's capabilities, its limitations, its quirks, its personality, if you will.
Like a practice round.
Exactly. Like a quick practice round to learn the tool before you play for real stakes.
That makes a lot of sense. Good planning helps the AI, sure, but maybe more importantly, it helps you manage the AI effectively.
Okay, what about the actual prompting, the interaction with the AI itself? Any specific best practices there for getting good, reliable code out of it?
Absolutely. The quality of your prompts directly impacts the quality of the output. So when prompting, the key is to be precise and atomic.
Precise and atomic.
Yeah. Avoid vague, open-ended prompts like build me an e-commerce app. That's way too broad. Instead, break down your requirements into the smallest possible focused tasks. And ideally, give the AI only one task at a time in each prompt.
So instead of saying create the entire user profile page, you'd start much smaller, maybe. Yep. Create the basic HTML structure for a user profile page with a header section and a main content area. Then the next prompt might be about adding specific fields to the header, and so on.
Why is that better?
This helps the AI stay focused and on track. And importantly, it helps work around the context window limitations of current LLMs. They can only remember so much of the conversation. Small prompts keep things manageable.
Okay, small focus prompts. Anything else?
Also, consider using a structured prompt framework. There are several emerging, like one called CLEAR. It stands for Context, Logic, Examples, Acceptance Criteria, and Relationships.
A framework for prompting.
Yeah. Using frameworks like that helps ensure your prompts provide the AI with all the necessary information, the context, the logic, maybe examples of what you want to generate higher quality, more contextually appropriate code. And finally, related to the context window issue, you absolutely must manage context windows carefully.
How do you do that?
Well, LLMs have finite memory. They genuinely forget things from earlier in a long conversation. So for complex projects, it's often crucial to start fresh chat sessions for each new major feature or component you're building. This avoids those context limitations that lead to AI amnesia and inconsistent or buggy code.
Start fresh chats.
Yeah. And when you start a new chat for a new feature, provide a concise summary of the relevant overall project context right at the beginning so the AI knows where it's picking up from.
Okay, so structured prompts, small tasks, careful context management are all key for getting good code. Once the code is generated, though, what about the quality and safety guardrails? What absolutely has to be put in place around the output?
Right, the output needs checks and balances. These are pretty much non-negotiable for any project that's intended to be more than just a personal experiment. First, absolutely mandate version control, like Git. This is foundational.
Use Git. Check.
Manually creating commits at stable, working checkpoints is often the only reliable way to recover when the AI inevitably makes a mistake and maybe overwrites or deletes functional code you needed. It's your essential undo button for the entire project's history.
Okay, critical safety net. What else?
Second, try to choose a popular, well-established tech stack. Stick to widely used and well-documented technologies. Things like Next.js for web apps, maybe Python for backend services, or Supabase for databases.
Why does it matter for AI?
Because the AI models have simply been trained on vastly more data, more examples for these popular stacks. And that generally results in higher quality, more reliable, and often more secure code generation compared to niche or obscure technologies.
More training data equals better output. Makes sense. Third,
Test early, test often. Don't wait until the whole feature is done according to the AI. Test each small piece, each small function immediately after it's generated. This allows bugs to be caught and fixed right away before they compound and create this cascade of failures that turns a small hiccup into a major disaster later.
catch problems when they're small.
Exactly. And finally, practice what you might call defensive prompting.
Defensive prompting, what's that?
It's about protecting your existing work. To prevent the AI from making unsolicited and potentially destructive changes, like suddenly deciding to delete a whole block of code you actually needed, you can explicitly include instructions in your prompts like no changes without asking or discussion only, do not write code when you're just brainstorming or exploring ideas with it.
Yeah.
It's about clearly signaling when you want it to generate versus when you just want it to discuss. It's about maintaining control.
Right, keeping the human firmly in the driver's seat. It really sounds like a lot of these emerging best practices are strong echoes of existing software development methodologies that have been around for a while. How does vibe coding, especially when used with these guardrails, align with or maybe diverge from established things like agile or test-driven development?
That's a really critical point, and exploring it helps us understand vibe coding's true place in the broader software development world. Because you're right, vibe coding doesn't exist in a vacuum. It's entering a mature industry that already has well-established methodologies.
So how does it fit in? Or does it?
Well, understanding its true potential and its limitations really requires analyzing how it aligns with and sometimes diverges from these foundational frameworks like agile or test-driven development, TDD. What we find, I think, is that vibe coding is less a replacement for these methodologies and more a powerful and sometimes quite disruptive force that both challenges and reshapes how they're applied. It's almost forcing us to reevaluate why we have these methodologies in the first place.
Interesting. Okay, let's start with agile. On the surface, the sheer speed of AI seems like it would be perfectly suited for agile's emphasis on rapid iteration and getting quick feedback loops going. Do they pair well together?
In some ways, they absolutely do. There are clear synergies. Vibe coding definitely appears to be a powerful accelerant for many core agile practices.
Like what?
For example, think about the agile principle of responding to change over following a plan. The flexibility and sheer speed of vibe coding align almost perfectly with that adaptability. When product requirements inevitably shift mid-project.
Which they always do.
Right. A team could potentially describe the new functionality in natural language and have the AI generate updated code with remarkable speed. Theoretically, this could shorten those adaptation cycles dramatically.
Faster pivots.
Exactly. It also seems to supercharge that rapid iteration and feedback loop, which is so central to Agile's build, measure, learn cycle. Teams might be able to generate functional prototypes or demos in hours rather than days or weeks. That allows for much earlier and more frequent user feedback, which means faster learning and quicker, more informed pivots based on real data.
And it helps deliver working software faster.
Yeah, by prioritizing the rapid creation of functional code, it directly supports that core agile principle of delivering working software frequently. You almost always have something tangible, something runnable, to show stakeholders or users.
Okay, so it sounds like potentially a perfect fit for Agile in many ways.
Mhm.
Or are there tensions? Are there other Agile principles where it might clash? It feels like that initial forget the code exists idea might rub up against things like, say, quality or team collaboration.
You're spot on. That's the friction. Despite these clear synergies, pure vibe coding, especially without strong guardrails, creates significant tension with other equally important agile values.
Such as,
Well, a core agile principle is maintaining a constant pace indefinitely. That's all about sustainable development, avoiding burnout, building quality in. The extreme speed often promised by pure vibe coding frequently comes at the direct expense of code quality. It creates that mountain of technical debt we talked about, which ultimately cripples future development speed.
so short-term game, long-term pain.
Exactly. That whole moving fast and breaking things mentality, while appealing initially, is fundamentally at odds with Agile's goal of long-term sustainability. Those initial productivity gains are often described as effectively being a high-interest loan taken out against the codebase's future. And eventually, those payments come due in the form of maintenance nightmares, painful refactoring efforts, and security holes that can grind all forward progress to a halt.
And what about the team aspect of Agile? Collaboration.
That's the other major tension. Agile frameworks, like Scrum, for example, are built on close collaboration within the development team. They emphasize practices like pair programming, collective code ownership, collaborative code review.
Right, the human interaction.
Yeah. Pure vibe coding, in contrast, can be a highly solitary activity. It's often just a dialogue between one human and the AI. This can really undermine the shared understanding, the collective code ownership, and that crucial peer-to-peer learning that are all critical for building robust, high-quality systems in an agile environment. If only one person vibed the code, and maybe they didn't fully understand it, and then they leave the team.
You're left with a black box nobody understands or can maintain.
Precisely. A huge liability.
It sounds like the true value of vibe coding within an agile context, then, isn't about ditching those established methodologies at all. Maybe it's about forcing a deeper appreciation for why they exist in the first place. It seems almost paradoxical.
That's a really profound observation, and I think it's absolutely true. What we're seeing is that when teams take the apparent shortcut offered by pure vibe coding, when they try to bypass the disciplines baked into agile and maybe test-driven development, they often very quickly experience the exact problems these frameworks were designed to prevent in the first place,
Like what?
like unmaintainable code, an inability to adapt to complex changes later on, and just a crippling lack of quality and predictability in their process. And this experience, ironically, it often leads to this powerful realization. The purpose of Agile isn't just speed, it's sustainable speed. The purpose of TDD isn't just about writing tests, it's about ensuring high-quality design, correctness, and long-term maintainability.
So the pain reinforces the value of the discipline.
Exactly.
Yeah.
Consequently, what you see mature teams doing is not abandoning their discipline frameworks for vibe coding. Instead, they strategically integrate vibe coding into those existing frameworks. Vibe coding becomes a powerful tool used within a sprint, maybe governed by pre-written tests, and always subject to rigorous human review and integration. In this way, its primary impact might actually be to powerfully reinforce the value of the very disciplines it initially seems poised to make obsolete. It proves their continued necessity, maybe now more than ever.
That's a fascinating reframe. Instead of killing discipline, it highlights why we need it. And speaking of essential disciplines, how do things like test-driven development, TDD, and this emerging concept of spec-driven development act as necessary counterbalances? You mentioned them as guardrails. They found like they could be the crucial safety nets for managing these powerful AI tools.
They absolutely are necessary guardrails, and maybe the most important ones for anyone looking to build something serious, something beyond just a hobby project, using AI assistance.
Yeah.
In response to those quality and maintainability challenges inherent in raw vibe coding, the developer community is increasingly turning to these more disciplined approaches. Test-driven development, TDD, which is the practice where you write your tests before you write the application code.
Right. Test first.
That's being adapted to create a more robust test-driven vibe coding workflow. And this process actually inverts the typical, more chaotic vibe coding flow. It puts the human firmly back in control of defining the intent and the correctness criteria up front.
Okay, so how does test-driven vibe coding work? You write the tests first, and then you let the AI try to make them pass, almost like giving it a challenge.
Precisely. That's a good way to put it. A human developer first writes a suite of automated tests. These could be unit tests for small functions, integration tests for how components work together, or even UI tests that simulate user interaction. These tests precisely define the desired functionality and the acceptance criteria for a new feature. They act as your clear, unambiguous specification for the AI.
The tests are the spec.
In effect, yes. Then the developer instructs the AI to generate the minimum amount of application code required to make those pre-written tests pass, often with the explicit instruction not to modify the tests themselves.
So the AI is constrained by the tests.
Exactly. And finally, and this step is absolutely crucial, the human developer carefully reviews the AI's proposed solution. They check it not just for passing the tests, but also for elegance, efficiency, security, and adherence to broader architectural standards and best practices.
Human oversight is key.
Non-negotiable. This approach aims to combine the incredible velocity of AI code generation with the rigor and quality assurance baked into TDD. It helps ensure that the final output is not just functional on a superficial level, but also correct, verifiable, and intentionally designed because its creation was driven entirely by those human-defined tests.
That sounds like a really smart way to potentially get the best of both worlds, the speed of AI, but with the quality control of TDD. Okay, and what about the other one you mentioned, spec-driven development? How does that fit in? You called it an architectural guardrail.
Yeah, spec-driven development is emerging as more of an architectural guardrail. It's specifically designed to combat that chaotic, prompt-driven nature of pure vibe coding, the approach that so often leads to poor overall system architecture and massive technical debt down the line.
How does it work differently?
Instead of immediately prompting the AI to start writing code for a feature, the developer using a spec-driven approach first instructs the AI to help generate a structured specification document. This is typically in a clear, human-readable format like Markdown.
So use the AI to help plan first.
Exactly. Get the AI to help you structure the plan. This document would outline things like user stories, detailed functional requirements, non-functional requirements like performance or security needs, and maybe high-level design considerations or component breakdowns.
And then what?
Then the human developer rigorously reviews, edits, and refines this specification. They curate it, making sure it accurately reflects the goals and constraints. It becomes this living document that serves as a clear, shared architectural plan before any significant application code is written.
Okay, so you have a solid plan vetted by a human.
Right. And then this validated specification is fed back to the AI, maybe piece by piece, as context for generating the actual code. This provides the AI with a much richer, more stable, and more coherent context to work from compared to just a series of ephemeral, disconnected chat prompts.
And the expected result.
The hope is that this leads to much better structured, more maintainable, and more architecturally sound code, because you're shifting the primary human effort away from downstream debugging and trying to fix messy, unplanned code and moving it upstream into careful planning and design, using the AI as an assistant in that planning phase too.
So essentially, you're getting the AI to help you plan the project thoroughly first, and then you build the code based on that clear human-vetted plan, rather than just asking the AI to somehow vibe the whole complex thing into existence with completely unpredictable architectural results. That feels like a significant and much safer shift in workflow.
It really is. It's about leveraging the AI for planning rigor, not just coding speed.
Let's really try and drill down now on how these different approaches truly contrast. You've laid out these three quite different ways of working. You've got pure vibe coding. You've got established agile Scrum practices, maybe with some AI assistance. And then you have these more rigorous TDD or spec-driven approaches integrating AI. Can you walk us through some of the core differences that really shape how a project feels and performs? Let's start with how they approach planning and design. How different is that initial phase?
Yeah, the approach to planning and design is probably one of the most stark contrasts between them. In what we've been calling pure vibe coding, planning is often minimal, sometimes almost an afterthought. It really embodies a code first, ask questions later, or maybe code first, refine later experimental philosophy. It's driven by that desire for rapid iteration and immediate gratification, seeing something work right away.
Okay, minimal planning for pure vibe. What about Agile Scrum?
With Agile and Scrum, planning is iterative. It's done in focused bursts, typically sprints, and the design is expected to emerge and evolve over time through constant team collaboration, feedback from stakeholders, and adaptation. It's very much a living, evolving plan, not a rigid upfront document.
And TDD spec-driven.
Those approaches put planning and design much more upfront, but in specific ways. Test-driven development centers its design process around writing the tests first. This forces you, the developer, to think very carefully about clean interfaces, dependencies, and exactly how the code should behave before you write the first line of application code. Spec-driven, similarly, front-loads the effort into creating that detailed, human-vetted specification document before major coding begins.
So the timing and nature of the mental design work are quite different. How about the actual code creation process itself? How does the code get written in each of these models?
That's another big difference. For pure vibe coding, the code creation is almost entirely AI-generated, driven by those natural language prompts. The human is essentially letting the AI do the typing and the heavy lifting of implementation based on high-level instructions.
AI does the coding. Agile Scrum.
In traditional Agile or Scrum, it's still primarily manual, collaborative coding done by the human development team members. They might certainly use AI assistants like Copilot for suggestions or snippets, but the humans are writing and owning the bulk of the code.
And TDD spec-driven with AI?
Here, it's often a hybrid. The AI might generate significant portions of the application code, but the process is highly constrained. In TDD, code is generated only to make a specific pre-written test pass. In spec-driven, it's generated based on a detailed pre-approved spec. So the AI's role is more about implementing a well-defined piece rather than inventing the solution.
Got it. What about the human's primary role then? What are they actually doing most of the time in each scenario?
In pure vibe coding, the human's primary role is really being the prompter, the guide, the tester, and the refiner. You're directing the AI, giving feedback, trying to steer it.
Okay.
In Agile Scrum, the human is a core team member, a collaborator, and an implementer. They're deeply involved in discussions, planning, coding, testing, reviewing every step.
And TDD spec-driven?
In TDD, the human is fundamentally the test author, the one who defines correctness and behavior up front. They're also the critical refactorer, constantly ensuring the code stays clean and meets quality standards. In spec-driven, they are the architect and the curator of the specification, the ultimate approver of the plan the AI helps generate code from.
Interesting. And what about the level of expertise needed to be effective in each model? Does vibe coding truly make software development accessible to everyone with low expertise? Or is there a hidden requirement there?
That's a really critical nuance. For very basic, simple tasks, pure vibe coding appears to require lower initial technical expertise because you're just typing plain English prompts. However,
There's a
big but. For effective guidance of the AI, for robust testing of its output, and especially for that painful vibe debugging when things go wrong, it actually demands surprisingly high expertise in things like problem solving, systems thinking, and understanding potential failure modes. It's easy to get started, hard to do well safely.
Okay. And the other models?
Traditional Agile and Scrum clearly require high proficiency in programming, software engineering principles, and crucially effective teamwork and communication skills. TDD demands high proficiency not just in coding, but specifically in testing frameworks. A deep understanding of software design principles like dependency injection, solid principles, and a very disciplined mindset to stick to the process.
So the expertise needed is different, but pure vibe coding isn't necessarily easier when things get complex or go wrong. That's a critical point. How about the actual debugging process itself across these? You called vibe debugging painful earlier. Can you contrast that?
Yeah, it really stands out. In pure vibe coding, as we discussed, debugging is often that frustrating, inefficient trial and error process. You're basically just feeding error messages back to the AI, hoping it magically figures out a solution, often without you fully understanding the root cause.
Okay, AI-driven guessing. Agile Scrum.
In Agile Scrum, debugging is typically more structured. It's based on human code comprehension, leveraging team collaboration, maybe pair debugging, and using systematic problem-solving techniques, along with debugging tools and shared knowledge of the system.
More systematic. TDD.
With TDD, you generally encounter far fewer bugs in the core application logic in the first place, because the tests act as an immediate validation net during development. So debugging often focuses more on understanding why a test is failing, which might be an issue in the test logic itself, or perhaps a rare edge case the initial tests didn't cover. It's usually more targeted.
Right, the tests guide the debugging too. Okay, pulling back a bit, what would you say is the key strength of each of these approaches? What makes them appealing or useful?
Good question. Pure vibe coding's key strength is undoubtedly its extreme speed, especially for initial prototyping and iteration. And its accessibility for non-coders is a huge plus, allowing very rapid experimentation.
Speed and accessibility. Agile Scrum.
Agile and Scrum really excel at adaptability. They're great for handling changing requirements, enabling the continuous delivery of business value, especially in complex, evolving project environments where you don't know everything up front.
Adaptability. TDD spec driven.
TDD's strength lies in producing high code quality, reliability, and long-term maintainability. It creates that crucial safety net for future refactoring and ensures the code actually does what it's supposed to do, verifiably. Spec-driven aims for better architectural integrity from the start.
Quality and correctness. Now, the flip side. What are the primary risks associated with each approach?
For pure vibe coding, the risks are profound, as we've covered. Potentially very poor code quality, severe security vulnerabilities, the accumulation of massive technical and epistemic debt, and ultimately the risk of creating completely unmaintainable systems. Big risks there. Agile Scrum.
Agile Scrum's risks, if not managed well, can include things like scope creep, where the project keeps growing uncontrollably, the potential for insufficient upfront architectural planning if the team isn't disciplined about it, and the possibility of team communication breakdowns hindering progress.
Manageable risks, but real. TDD.
TDD can sometimes be slower initially because you have the overhead of writing the tests first before you see application code working. There's also a risk of potentially overtesting trivial code or writing tests that are too brittle if the practitioners aren't experienced in applying it judiciously.
Okay. So finally, wrapping up this comparison, what's the ideal use case for each? Where do they truly shine and make the most sense?
Pure vibe coding, given its strengths and risks, seems ideal for things like rapid prototyping, creating quick MVPs to test an idea, building internal tools where security exposure might be limited, running hackathons, and also as a powerful learning tool for developers exploring new technologies.
Experimental, low-risk scenarios. Agile Scrum. Agile Scrum is generally best for complex, evolving products where the requirements aren't fully known or are expected to change significantly up front, and where continuous feedback from users or the market is essential to guide development.
Complex, evolving products. TDD spec-driven.
Test-driven development is best suited for mission-critical systems that require very high reliability, correctness, and long-term maintainability. Think financial systems, healthcare applications, core infrastructure places where bugs are simply not acceptable or have severe consequences. Spec-driven aims to bring better structure to projects that need more architectural foresight than pure Agile might provide alone.
High-stakes, long-term systems.
Yeah.
Wow, that comparison really clarifies things. It clearly shows how those traditional methods or adaptations of them really act as essential counterbalances and frameworks for managing the raw power and the significant risks inherent in just pure, unadulterated vibe coding.
Exactly. It's about finding the right tool and the right process for the job at hand, which inevitably raises the big question. Where is all this heading? Where is vibe coding actually going? Is it just going to remain a hobbyist trend, something bubbling on the fringes, or is it truly destined for mainstream enterprise reality? The future here is a subject of really fierce contention. There are compelling arguments on both sides.
Okay, let's explore that. Give us the bull case first. What's the optimistic outlook? What's the vision of where this technology is headed in the enterprise?
Well, the proponents, the optimists, argue that what we're seeing is an AI coding gold rush, and that vibe coding isn't just a passing fad. They see it as a fundamental, irreversible shift in how software will be created.
A true paradigm shift.
That's the view. And this view is supported by some pretty attention-grabbing market forecasts from major industry analysts. Gartner, for instance, they've made the extremely bold prediction that 0% of all new enterprise production software will be created using vibe coding techniques and associated tools by the year 2028.
40% by 2028? It's huge and not far away.
It's a massive scale. 2/5 of new enterprise software potentially driven significantly by AI generation. And we're already seeing the rapid financial success of startups operating in this space. We mentioned Lovable earlier. They reportedly hit over $100 million in annualized revenue very shortly after their launch. That demonstrates real commercial viability and market demand.
So the money is flowing in.
It seems so. The core argument for the bull case really boils down to this. The potential productivity gains, the ability to rapidly iterate and get products to market faster, and maybe the capability to bypass those persistent developer skills shortages. These factors are simply too compelling for enterprises to ignore in the long run. And surveys seem to back this up. One found that 90% of professionals believe vibe coding will become more relevant in the future, at least for certain niche use cases. That deficiency argument alone is incredibly powerful.
Okay, that's a strong argument for inevitability, especially with the Gartner prediction and the clear commercial interest. But what's the bear case? Why are some skeptics pushing back hard, saying it's fundamentally not enterprise ready, maybe even that it's a dangerous path for serious businesses to go down right now?
The skeptics and critics, often experienced engineers and architects, maintain that pure vibe coding, in its current form, is fundamentally unsuitable for the rigorous demands of the enterprise environment.
Why specifically?
They argue that the immense and often hard-to-manage risks associated with security, reliability, scalability, governance, and especially long-term maintainability are just far too great for mission-critical systems. The kinds of systems that handle sensitive customer or financial data, that power core business operations, or that face stringent regulatory compliance requirements.
The stakes are too high.
Exactly. This perspective often views the current hype around vibe coding as a potentially dangerous marketing campaign that conveniently overlooks the harsh realities and complexities of the full software development lifecycle. It prioritizes that flashy initial speed over enduring quality and stability, while acknowledging its utility for hobbyists or maybe internal prototypes. Yeah. These experts warn that applying these techniques wholesale to complex systems built to scale and last for years is premature, maybe even reckless. It's like, as one source put it, trying to build a skyscraper using materials and techniques meant for a garden shed.
Doesn't sound stable.
No. And critically, that trust issue remains. Trust in the reliability and security of AI-generated code is still relatively low among its primary users, the developers themselves. Remember those stats? While maybe 76% of developers are using or plan to use AI tools, only around 43% say they actually trust the results completely. That's a significant trust deficit that needs to be overcome before widespread, uncritical adoption in high-stakes environments.
So it really sounds like there's a clear cultural divide opening up here. You've got the enthusiasts, maybe creatives, designers, entrepreneurs, seeing the potential for innovation, and then the more cautious, experienced engineers worried about the downsides. It sounds like two different worlds looking at the same thing.
Absolutely. You see that playing out.
Mm-hmm.
Creatives, designers, entrepreneurs, they tend to be much more positive. They often embrace vibe coding as this exciting tool for playful exploration, for rapid innovation. They're focused on the outcome, the speed to market, getting the idea out there.
Right.
In contrast, many experienced software engineers express much more negative or skeptical views. They often fear that it devalues their craft, that it encourages poor practices that inevitably lead to these unmanageable, brittle systems, and that ultimately it just contributes to a flood of low-quality, insecure software that they will be the ones tasked with fixing and maintaining later. It's a fundamental clash of priorities and perspectives based on experience.
Yeah. Understandable friction there. This obviously raises the huge question, what does all this mean for the role of the software engineer? Are they going to be replaced by AI, as some headlines scream? Or is this just another, albeit very powerful tool in their kit that changes how they work?
That's the million-dollar question, isn't it? But there seems to be a broad consensus emerging among most experts in the field. The consensus is that vibe coding and related AI technologies will not eliminate software engineers entirely. However, they will profoundly transform the engineer's role.
Transform how?
The value proposition for a human engineer is going to increasingly shift. It'll move away from the purely mechanical act of writing lines of code, which is a task that is clearly becoming increasingly automatable by AI, and it will shift towards higher-level, uniquely human skills. Skills that AI, at least currently, cannot replicate well.
Like strategic thinking.
Exactly. Things like deep system design, critical thinking, complex problem solving, security auditing, and architectural planning. The bottleneck in software creation seems to be shifting away from raw development speed and moving towards knowing which problems are actually worth solving and then architecting the right solution effectively. The engineer becomes more like the conductor of the orchestra, not just one of the musicians playing an instrument.
So what kind of specific skills will the engineer of the future really need to cultivate to thrive in this new landscape? If someone listening is an engineer, what should they be focusing on developing right now if they want to stay relevant and valuable?
That's crucial. The software engineer of the future will likely need to operate effectively in several key capacities, leveraging AI rather than competing with it on code generation. First, they'll need to be a strong system architect and specifier.
Defining the blueprint.
Precisely. Defining the high-level structure, the technical requirements, the architectural constraints within which AI tools can then operate safely and effectively. This involves creating that robust spec in spec-driven development, ensuring the overall blueprint is sound before the AI starts filling in the details. Second, they'll increasingly be an AI code auditor.
The quality gatekeeper.
Exactly, acting as that critical quality gatekeeper, rigorously reviewing and vetting all significant AI-generated code for those hidden security vulnerabilities, performance bottlenecks, maintainability issues, and adherence to established best practices and organizational standards. This is where human judgment and deep experience become absolutely indispensable. AI can't audit itself effectively yet.
Okay, architect and auditor, what else?
Third, they'll remain the complex problem solver, focusing their energy on the most challenging aspects of software engineering, things like developing truly novel algorithms, designing intricate system interactions, or solving unique business problems that fall well outside the pattern-matching capabilities of current LLMs, the stuff AI hasn't seen before. And finally, maybe a role as a synthesizer and connector,
What does that mean?
integrating knowledge across different domains, product design, marketing, business strategy, and engineering, to identify those novel intersections and opportunities for true innovation. They'll be the bridge builders, the ones who see how to connect the dots in ways the AI can't.
It really sounds like a significant move up the value chain, focusing much more on higher-order thinking, strategy, and quality assurance, rather than just cranking out lines of code. And this transformation, it seems likely it will create different career paths or tracks for engineers moving forward.
That seems like a very likely outcome, yes. This evolution will probably create, or at least accentuate, two distinct career tracks for software engineers. On one path, you'll have those who truly master the fundamentals of computer science, who develop deep architectural expertise, and who learn how to effectively direct, manage, and critically audit these powerful AI systems. These engineers will likely become the highly valued strategic thinkers and technical leaders.
The AI wranglers and architects.
You could put it that way. And then there's the potential for another track. Those engineers who might become overly reliant on the AI tools, maybe without building that deeper foundational understanding. They might find themselves unable to function effectively without the AI, lacking the critical grasp of underlying systems needed to solve complex problems or create genuine strategic value beyond just prompting. The ability to abstract, reason critically, and understand fundamentals will likely become paramount.
A crucial distinction for career planning. Now, going back to the enterprise context for a moment, you said earlier that the whole debate about whether vibe coding is enterprise ready might actually be a red herring. What did you mean by that? Are we trying to keep this genie in the bottle, or is it maybe already out and wandering around the office?
Yeah, I think that's a critical insight for technology leaders grappling with this right now. That ongoing debate, is it ready? Should we allow it? It might indeed be a red herring, because the more salient reality in many organizations is that AI-assisted coding is already inside the enterprise, whether it's officially sanctioned or not.
Happening under the radar.
Often, yes. With such a high percentage of developers already using AI coding assistants like Copilot in their daily workflows, frequently on an individual basis, sometimes quietly, without explicit permission, the technology is effectively being adopted from the bottom up. So a strategy of just waiting until the practice is deemed perfectly ready for some big top-down official rollout that feels like a passive approach that ignores the current reality on the ground.
So what's the alternative?
The more effective strategic challenge for leaders, I believe, is not trying to keep vibe coding out, but figuring out how to ensure its use is enterprise contained.
Enterprise contained, meaning?
Meaning you need a proactive approach, one focused on creating the necessary policies, the training programs, the technical guardrails required to make its use visible, managed, and aligned with your existing enterprise standards for quality, security, compliance, and intellectual property. The goal for technology leaders should probably be to channel the vibe, harness that energy and potential into productive and safe outcomes, rather than attempting to forbid a tool that's likely already in widespread, albeit possibly hidden, use.
That's a much more pragmatic approach. So if you're a CTO or a VP of engineering or a tech lead listening right now, and you're wrestling with these exact questions about how to manage the influx of AI in your teams, what's the proactive strategy? What are the concrete steps leaders should be thinking about taking now?
Okay, based on the analysis, there are several key recommendations. The first, and maybe most fundamental, is to adopt a clear trust but verify mandate across the organization.
Trust but verify. Classic.
Exactly. Embrace AI coding assistants as potentially powerful productivity multipliers for your team. They can make developers faster and potentially happier, but do not blindly trust their output. Establish a clear, explicit, and non-negotiable policy that all AI-generated code, regardless of its source or how trivial it seems, is subject to the same rigorous quality and security standards as human-written code.
What does that mean in
It
practice?
means things like mandatory human-led code reviews for any critical systems or features touched by AI-generated code. It means comprehensive automated testing suites that cover AI output. And it means thorough security scanning using sophisticated tools. It's not enough to just run a simple linter. You need deep, critical scrutiny by experienced humans.
Okay, mandate verification. But how do you decide where to even allow these tools and where maybe to restrict them, given the huge range of projects and risk levels within a typical enterprise?
That's where you need a segmented, risk-based adoption strategy. It's crucial not to apply a one-size-fits-all policy to vibe coding or AI assistance. Instead, segment its use based on the specific risk profile of the project or system.
How would that segmentation look?
You could potentially greenlight it for low-risk applications. Actively encourage its use for things like rapid prototyping, developing internal tools that have limited security exposure, creating proofs of concept for new product ideas, or running internal hackathon-style innovation challenges. Let people experiment where the stakes are low.
Makes sense. And the high-risk areas?
Conversely, you should probably red light or heavily restrict its use for high-risk applications. That means you either forbid pure vibe coding entirely or place very stringent restrictions and oversight on its use for things like mission-critical production systems, applications that handle sensitive customer or financial data, PII, systems with high-performance requirements, or strict regulatory compliance needs, like healthcare or finance, and especially your core, long-lived products that are central to the business's revenue or reputation. The potential downsides in those areas simply far outweigh the perceived speed gains from letting the AI run unsupervised.
So tailor the policy to the risk. Beyond just setting rules, it sounds like the real ongoing investment needs to be in the processes and the technical systems around these tools, the guardrails you keep mentioning.
Exactly right. You absolutely must invest in the guardrails, not just the shiny new AI tools themselves. The most critical investment, arguably, is not in procuring the latest AI coding assistant, but in building and maintaining the disciplined framework that governs its use effectively.
What does that framework include?
Well, it should include several types of guardrails. First, process guardrails. This means formally adopting and, importantly, training your teams on structured methodologies like spec-driven or test-driven vibe coding for any AI-assisted project that's intended to move beyond the initial prototype stage. Make the disciplined approach the default for serious work.
Okay, process guardrails. What else?
Second, technical guardrails. This means integrating automated security tools like SAST, Static Application Security Testing, which scans your source code before it even runs, looking for potential flaws, and DAST, Dynamic Application Security Testing, which actively probes your running application for vulnerabilities. Plus, things like SEA, software composition analysis tools to continuously check all those third-party libraries your AI might pull in for known security issues.
Automate the safety nets.
Precisely. Build these automated safety nets right into your CI/CD pipelines, your continuous integration and continuous deployment process, so they run automatically, catching potential issues early before they reach production. And finally, you need policy guardrails.
Clear rules of engagement.
Yeah. Developing and clearly disseminating organizational policies for how engineers should interact with AI tools. This could include establishing specific cursor rules or similar prompt engineering guidelines that enforce best practices for consistency, for security, like not pasting sensitive code into public AIs, and for ensuring proper documentation is generated alongside the code across the entire organization.
Process, technical, and policy guardrails. Makes sense. And what about the people, the talent within the organization? How do you prepare your engineers for this new world, and what skills should leadership be actively cultivating in their teams?
That's maybe the most important long-term investment. You absolutely need to upskill your talent for this new engineering paradigm. The rise of AI necessitates a strategic shift in how you think about talent development and assessment. You likely need to reevaluate your training programs, your hiring criteria, even your promotion criteria, to prioritize the skills that AI cannot easily replicate. Focus on cultivating things like deep architectural thinking, the ability to design resilient, scalable, maintainable systems. Robust security expertise is going to be more valuable than ever. Critical and systems-level problem-solving skills for tackling complex, novel challenges are key. And of course, the ability to effectively prompt, guide, critically evaluate, and audit these AI systems themselves becomes a core competency.
So value shifts from pure coding speed to judgment and oversight.
Exactly. The future value of your engineering team will likely be measured less by their raw coding speed or lines of code produced, and much more by their judgment, their creativity, their strategic insight, and their ability to ensure quality and security. You need engineers who can ask the right questions of the AI, deeply understand its answers, and validate them rigorously.
That makes so much sense. Okay, let's quickly review some of those detailed risk mitigation strategies the sources provide, just to really hammer them home, maybe category by category. For security, given that alarming 40% potential flaw rate, what are the specific process and tooling mitigations people should be implementing?
Okay, for security, the specific threats we're worried about include things like the AI using insecure dependencies or outdated libraries, generating code vulnerable to injection attacks like SQL injection or cross-site scripting XSS, or maybe implementing improper authentication or authorization logic.
Right, so process mitigations.
On the process side, you absolutely must mandate rigorous security code reviews conducted by experienced humans for all significant AI-generated code, especially any code that touches sensitive user data, financial transactions, or integrates with external systems. Also, conduct regular security training for your developers that focuses specifically on the risks introduced by AI tools and how to mitigate them through secure prompting and review.
And tooling for security.
For tooling, definitely integrate those automated security tools, SAST, DAST, and SCA, directly into your CI/CD pipeline, so they run on every build. These tools will automatically scan for many common vulnerabilities. Additionally, encourage the use of security-focused linters and specialized IDE plugins that can provide real-time feedback to developers while they are prompting the AI or reviewing its output. Catch things earlier.
Okay, security covered. What about maintainability and that really tricky epistemic debt, that hidden house of horrors in the code base? How do you fight that?
Right, for maintainability and technical debt, the specific threats include that unstructured spaghetti code we talked about, a lack of documentation making the code incomprehensible later, inconsistent coding patterns across the project, and that big one, epistemic debt, where the code works but nobody truly understands how or why.
Process mitigations for maintainability.
Process-wise, strongly enforce a spec-driven development approach for project planning, ensuring there's a clear, agreed-upon blueprint before major coding begins. Adopt test-driven vibe coding, where appropriate, to ensure verifiable functionality and that the code's intent is captured in the tests. You should also require the AI to generate documentation alongside the code it produces, and then have humans review and enhance that documentation. And of course, mandate the use of version control like Git with meaningful descriptive commit messages so you have a clear history of changes that you can actually understand later.
And any tooling to help with maintainability.
Yes. Utilize automated code formatters like Prettier and style checkers like ESLint to enforce consistency across the code base automatically. And consider using AI development tools that offer persistent project memory or context, which can help maintain consistency across multiple AI interactions within the same project, reducing conflicting outputs.
Good tips. Finally, what about those scalability and performance issues that often crop up with quickly built prototypes when they hit real-world load?
Yeah, the threats there typically include the AI choosing inefficient algorithms, generating unoptimized database queries, like that select on a huge table, or generally poor resource management in the code.
How do you mitigate those through process?
Process mitigation strategies should include requiring formal architectural reviews conducted by senior engineers for any vibe-coded project that's intended for production release. Ensure it's actually designed with scalability and performance in mind from the outset, not just bolted on later. Also, you should probably prohibit the use of pure, unreviewed vibe coding for core, high-load systems entirely, unless there's expert human oversight and a very clear, predefined architectural design being followed.
And tooling for performance.
For tooling, definitely implement automated performance and load testing as part of your deployment pipeline. Simulate real-world user traffic before you launch to identify bottlenecks early. And use database query analysis tools, most databases offer these, to identify and flag inefficient or slow queries that would likely cripple performance under significant load. Be proactive about performance. Don't wait for users to complain.
Excellent breakdown of the mitigations. So, okay, let's try to wrap this up. What does this all really mean? As we finish this deep dive, it seems crystal clear that vibe coding offers this incredible, almost intoxicating blend of speed and accessibility. It truly represents a potential democratization of software creation, maybe allowing more people to build things with technology than ever before. That feels like a genuinely monumental
It
shift.
really does. The potential is huge.
But, and it's a big but, as we've thoroughly explored today, it comes with these significant, often hidden risks. We're talking about pervasive security vulnerabilities, potentially crippling code quality issues that lead to maintenance nightmares, and that insidious epistemic debt that can secretly undermine and eventually sink entire projects.
That's the core paradox right there.
Hmm.
And the true value, the path forward, it seems, isn't in abandoning traditional discipline entirely, as tempting as that might initially sound when you first see the dazzling speed of AI generation.
Right.
Instead, the value lies in strategically integrating vibe coding into our established, proven engineering practices. It's about making its use enterprise-contained, as we discussed, ensuring its undeniable power is harnessed responsibly within a robust framework of verification and oversight. It's not about trying to keep it out of the enterprise entirely because, frankly, that battle is probably already lost anyway.
So embrace it, but manage it carefully.
Exactly. Vibe coding is an incredibly powerful tool, there's no doubt about that, but it's one that absolutely demands responsible application. It's not a magic wand that solves all problems. It's more like a powerful, sometimes volatile new ingredient that requires skill and care to use effectively without causing harm.
This really raises a final important question for everyone listening to think about. As AI continues to reshape not just how we build software, but maybe even who gets to build it, will the ultimate measure of innovation itself begin to shift? Will it move away from simply how fast we can create something towards how thoughtfully, how reliably, and how securely we can govern what the machines produce?
That's a deep question.
And if that's the case, what responsibility does that shift put on your shoulders, whether you're a developer, a manager, a founder, or just someone interacting with technology as you navigate this rapidly evolving and frankly quite exciting landscape?